Okay, we are going to go through a few free body diagram examples. Remember that all forces acting on the object need to be illustrated. A force is a vector, so we're going to be drawing arrows, magnitude and direction for those individual forces. We should now consider friction unless the problem tells us different. As we go through our examples, we're going to see that we are given the phrase, consider friction, consider air resistance. We're just trying to remind you that in this chapter, we do need to always consider our frictional forces or our air resistance unless the problem tells you different. Remember, all of the vectors have to point outward from the box. Anytime we create unbalanced force pairs, that means the object is going to experience an acceleration. So let's try our first one. It says that we have a book at rest on a tabletop. So we have my book. Remember, every object is a square. The first vector for every free body diagram needs to be a downward vector. And we're going to label that FG. We know that gravity acts on all of our objects, so the force due to gravity needs to be present in every illustration. The only reason we would not have a force due to gravity is if we are in far outer space where we are out of the gravitational pull of the moon, the sun, the earth, Jupiter, Mars, anything that has a gravitational pull. We have to be far enough away that we are outside of that gravity's range. Okay, so far outer space is the only time we have no FG. Otherwise, this is the first vector. This object right now is being shown to have an acceleration because this is unbalanced forces acting in the downward direction. So what we need to understand is if the box is at rest, it is not accelerating downward. So we must have some force acting upward in order to cancel out the effects of gravity. Again, if we think about real life, we know that the book would fall because of gravity, but if it's resting on the table, well, that's because there is a force because of the contact with the table. And so that's what we are going to label as our normal force. And in this case, these two forces would need to be the same length. And so those little math signs there, we're going to use that to help us out. So we know that these are the same magnitude. So this would be an object at rest on the table. It is not accelerating upward, and it is not accelerating downward. It is balanced. An egg free falling from a nest in a tree. There's my egg. There's my force due to gravity. And this is it. This is my whole picture. It says in the problem for me to neglect air resistance, so I only have the gravitational force. If the question wanted me to consider air resistance, now I have a frictional force because of the air acting on the object. The object is moving downward, so friction is in the opposite direction. So that means I would have some frictional force here. Now, you are going to want to draw this on your free body diagrams in places where it doesn't belong. So you've got to make sure you understand what is happening. When should the frictional force be less than gravity? When should it be more than gravity? When should it be equal to? Again, we're evaluating our picture. If there's no acceleration, then it has to be because the forces are balanced. If it is accelerating, then one arrow must be longer than the other. And so then that's going to help us know which one gets the bigger value. So we have our frictional force upward, our gravitational force downward. The force due to gravity is larger. So my object is going to accelerate in the downward direction, even if we consider our frictional force. A force is applied to a book to move it across a desk with the rightward acceleration. Consider frictional forces, neglect air resistance. Chances are you were able to come up with these two force vectors from the reading. Every object is going to have a downward force due to gravity. Now, it did not talk about the gravitational force. It did not talk about anything working on the vertical axis with the gravitational force. So here we have to understand that gravitational force is going to have a force canceling it out in this case, because if this is a book and it is on a desk, that book is not accelerating downward through the desk, and it is not accelerating upward off of the desk. So once I comprehend that, now I can say there must be an upward force that is equal magnitude to gravity. And if I stop and think about it, that would be the normal force because of the contact that the book has with the desk. Now, it says horizontally, it has a rightward acceleration. So I'm going to draw my applied force to the right, specifically to the right, because the acceleration is to the right. And then it tells me to consider frictional forces. Again, eventually that needs to be automatic for you, okay? So it says that we have consider frictional forces. We have friction, so friction should be pointed in the opposite direction of the motion. Now, how do you know that friction should be less than, equal to, or greater than the applied force? In this case, it says that it is accelerating. And remember, we said acceleration means unbalanced forces so that the object can experience a change in its motion. So when you see acceleration, that means my forces are unbalanced. And if the acceleration is to the right, then the applied force, which is to the right, must be larger than my frictional force. So there's my free body diagram for this statement. A car coasting to the right. Now this is a unique situation. I am going to go ahead and draw my normal force and my gravitational force. Gravity is acting downward on the object. The car is on the road. It is not accelerating down through the street, and it is not accelerating up off of the road. So that means that these two values are balanced. Now, if the object is slowing down, you have to decide what direction is the object moving. If you want the object to be moving to the right, then in order for the object to be slowing down, there must be a frictional force working against that motion. And if this is the only force acting on my object, then my object is going to be slowing down, because friction is an unbalanced force that's working against the object's inertia, against the object's original motion. Okay, so those are your examples for free body diagrams. Now you guys need to go and try the first page in your packet, which is free body diagram practice.